Good morning, students. Today we are going to learn about symmetry, chapter 14 of your textbook. In your previous class, you have learned line symmetry. Now let us recollect the important points. A figure has a line symmetry if there is a line about which the figure may be folded so that the two parts of the figure will coincide. So in nature, when you observe, we can find symmetry all around us. The concept of symmetry is extensively used by artists, professionals, designers of clothing or jewelry, car manufacturers, architects, and many others. So in the figures which are shown here, you can see the line of symmetry in the field of architecture, in case of engineering, and also when you observe to the nature. So we can see symmetry all around us. Now see, here in these figures, the lines of symmetry are marked with dotted lines. There are 4 figures given in figure 14.1. The dotted lines shows the line of symmetry. Now we can see line of symmetry for regular polygons. What is a regular polygon? A polygon with all the sides of equal length. For example, equilateral triangle, a square, a regular hexagon, regular pentagon. All these are examples of regular polygons. And each regular polygon, it has as many lines of symmetry as it has sides. That means the number of lines of symmetry same as that of the number of its sides. For example, a regular hexagon. Hexagon means how many sides? 6 sides. So a regular hexagon has 6 sides. So it has 6 lines of symmetry. An equilateral triangle. There are 3 sides. So the lines of symmetry for an equilateral triangle, it is 3. A square, 4 equal sides. So there are 4 lines of symmetry. Now look at the figure 14.6. It's already drawn the lines of symmetry for equilateral triangle, square, regular pentagon, and regular hexagon. Is that clear? Now, what is meant by mirror reflection? You must have observed that when you stand in front of a mirror, the left side appears to be the right and right appears to be the left. That means the left-right changes. Line symmetry is closely related to mirror reflection. In mirror reflection, there are left-right changes as it is shown in the figure. See the letter R, how it appears in a mirror. See the mirror reflection of the rat, which is shown in the second figure. So there are left-right changes which are seen in a mirror. So the next topic, it is rotational symmetry. Till now what we have learned, it is line symmetry. Now we can see what is rotational symmetry. When an object rotates, its shape and size do not change. The rotation turns an object about a fixed point, and that fixed point is called as the center of rotation. So the fixed point at which an object rotates, it is called the center of rotation. The angle of turning during rotation is called angle of rotation. So how much angle the object is rotated or turned, it is called the angle of rotation. When an object makes a complete turn, a full turn, complete rotation, then the angle of rotation is 360 degree. So if complete rotation, the angle is 360 degree, or a complete turn, the angle is 360 degree, then for half turn it is 180 degree, and for quarter turn it is 90 degree. Now, order of rotational symmetry. See the figure 14.12 here. Here the different positions of a windmill it is shown. During a single rotation, there are certain positions when the windmill looks exactly like the original position. So we say that the windmill has rotational symmetry. And in a full turn, there are precisely 4 positions. When the windmill makes a complete turn, the 4 positions, it looks exactly the same. And when it makes an angle, when it turns through 90 degree, turns through 180 degree, then 270 degree and 360 degree. In these 4 angles, the windmill looks exactly the same. So we say that the order of rotational symmetry, it is 4. And the angle of rotation, it is 90 degree. Is that clear? See the case of a square also. In square also, in every 90 degree, means first 90 degree, then 180, then which is the next one, 270, and then 360. So it looks exactly the same. So each 90 degree, it looks the same. So the order of rotation, it is 4 in case of a square also. See here also some rotational symmetry. For some figures, it is shown there. Then line symmetry and rotational symmetry. You know that some figures have only line symmetry and some have only rotational symmetry. But there are certain figures which has both line symmetry and rotational symmetry. For example, the case of square shape. A square has 4 lines of, how many lines of symmetry? It has 4 lines of symmetry. Same way, what's the order of rotational symmetry? That also 4. The circle. It is the most perfect symmetrical figure, because it can be rotated around its center through any angle at the same time. It has unlimited number of lines of symmetry. When you observe any circular pattern, every line through the center, that means through the diameter, forms a line of symmetry, and it has rotational symmetry around the center for every angle. So we can say that here, for example, the square and the circle, it has both line symmetry and rotational symmetry. Same way, an equilateral triangle also has line symmetry and rotational symmetry. Like that, there are many figures. We can find out the figures which has both line symmetry and rotational symmetry. I hope the topic is clear to you. Go through the textbook and try to solve the exercises which are given in your textbook. Thank you.